All right, good morning, mathematicians. Um, I apologize that I'm not there today to welcome you guys back, but um, I will be there on Thursday, I promise. Um, well, anyway, even though I'm not there, the learning must continue. I hope you guys had a wonderful winter break, and I can't wait to hear about it in those New Year's surveys. All right, so we're going to dive right in. I'm on page 41. This is lesson 2.5. We're still talking about these linear models, um, writing equations for them, comparing them, getting information from them. Okay, so we're going to take a look at these two companies. One is an amusement park, and the other is a movie theater. So question A says, use a table to find linear functions relating the probability of rain P to the following quantities. 1 is the Saturday attendance F at Big Fun. 2, Saturday attendance at R, or R at Get Real. Okay, so first thing to note is that they actually define the variables that they want us to use. So they say that P is the probability of rain. Which is a column or a row in the table here. They tell us that F is the attendance at Big Fun. And then they tell us that R is the attendance at Get Real. Okay, so this is a bit of a review here. We need to write linear models that represent the attendance at both of these places and relate it to the probability of rain. Okay, so we're trying to write an equation, remember, y equals mx plus b. But in this case, our y is going to be either f or r. Right, so we're looking for the attendance, and the equation, we're going to use the probability of rain to help us find that out. So we need some sort of slope for both of these. We need our independent variable, which is the probability of rain. And then, of course, we need our y-intercept. So let's review quickly how to do that. Well, remember that you need a slope and you need a y-intercept to write an equation of a linear model. So let's go ahead and do this for Big Fun. Okay. It's important to know, and I'll say this again, that the probability of rain is going to be our independent variable, or our x, and then the attendances at either place are going to be our dependent variables, or our y's. Okay, so what I'm going to do is I'm going to pick 2 points from this table. So I like to keep it simple. There's 0, 1,000, and then let's just use the next point, 20 and 850. So I'm going to write those 2 points here. So 0, 1,000, and 20, 850. We need to find the slope between these two things. So before the break, we talked about the slope being the change in y over the change in x. So looking at my y coordinates here, to go from 1,000 to 850, right, it looks like I'm subtracting 150. So that right there is my change in y. To go from 0 to 20, it looks like I'm adding 20, and that is my change in x. So I'm going to write my ratio, change in y over change in x, so that's negative 150 over 20. And in this case, we're going to simplify it to a decimal here, so go ahead and type that into your calculators, and you should get negative 7.5. Okay, now we need the y-intercept here. Now hopefully you guys remember that the x-coordinate of all y-intercepts is 0. Do they give us the y-intercept in the table here? Well, hey look, I have a 0 in my x-coordinate, and the corresponding y-coordinates are here. So actually, I don't really need to do much work to find the y-intercept here. So I know that my m is going to be negative 7.5. My y-intercept, or b, is going to be at 1,000. So when I write the equation for big fun, that's going to be negative 7.5, which is m. I multiply it times the probability of rain, and then I add 1,000. And there we go. All right, let's do the same thing for get real. I'm going to pick 2 points. I'm going to stick with the first 2 points here. So there's 0, 300, and 20, 340. And it's good to know, you guys, that it doesn't matter which 2 points you pick. What's nice is that they tell us it's a linear model, so we can really pick any of the points on this table or any 2 points on this table, and you should be able to write the equation. You'll get the same answer. Okay, so I'm going to calculate my change in y over change in x. And let's see, so 300 to 340, it's a positive increase, so that's my change in y. And then 0 to 20 is another positive increase, and that is my change in x. So change in y over change in x, that's the same thing as 4 over 2, which is the same thing as 2. So it looks like my slope is 2, and my y-intercept, which is given to me by my table here, which is 300. So the equation for get real, remember r, right, r stands for the attendance at get real, is equal to my slope, which is 2, times the probability of rain, plus the y-intercept, which is 300. And there we have my 2 equations. Okay, now it's important that you guys can write these equations because the rest of this lesson is going to be using them, right? Using them to figure out certain information. Okay, so let's continue. B, it says use your functions from question A to answer these questions. Show your calculations and explain your reasoning. Suppose there is a 50% probability of rain this Saturday. What is the expected attendance at each attraction? And then we give you guys a little hint here. When P equals 50, what does F equal and what does R equal? Okay, so we probably should rewrite our equations here. So for big fun, we said that it's negative 7.5 P plus 1,000. And then for get real was R equals 2P plus 300. Okay, so go ahead and pause the video here. See if you can determine what is the expected attendance if there's a probability of rain, if there's a 50% chance of rain. All right, hopefully you pause the video and you try this on your own. So important thing to know is that P is equal to 50. So I'm going to just plug in 50 into my equation here. So negative 7.5 times 50 plus 1,000. And that simplifies to negative 7.5 times 50 is negative 375. Then I add 1,000. So it looks like the attendance when there's a 50% chance of rain is going to be 625 people. Okay, again, it's good to write in what this number represents. So not just 625, but 625 people. That would be the attendance if there's a 50% chance of rain. All right, then we do the same thing for get real. So we're going to plug in 50 for P. So 2 times 50 plus 300, which is 100 plus 300, which equals 400. And of course, this is F. All right, so 400 people will be there at Get Real if there's a 50% chance of rain. All right, let's keep going. Suppose 475 people visited Big Fun one Saturday. Estimate the probability of rain on that day. So some keywords here. Suppose 475 people visited Big Fun. Visited Big Fun one Saturday. Estimate the probability of rain on that day. So When f equals 475, what does p equal? So let's rewrite our equation here. F is equal to negative 7.5p plus 1,000. Now, they give me f, so I'm going to plug in that value for f here, and then I must solve for p. So now my equation looks like this. 475 equals negative 7.5p plus 1,000. Now your job is to solve for p. So go ahead and pause the video here and solve for p. Isolate the variable, please. All right, hopefully you guys pause the video. Quick review of solving equations. So we got to get rid of that 1,000 first. So I'm going to subtract 1,000 from both sides. So I get negative 525 over here. And that is equal to negative 7.5p. Okay, and then to get p by itself, I'm just going to divide by negative 7.5. Just make sure that you're dividing both sides by negative 7.5. So these 7.5s cancel out. And then negative 525 divided by negative 7.5 is going to give me 70. So p equals 70. I need to translate that into, for the people who are probably going to be looking at our work. What does p equals 70 mean? Well, p stands for the probability of rain. So the probability of rain is at 70%. And there we go. Okay, let's keep going. Number 3, what probability of rain gives a predicted Saturday attendance of at least 360 people at Get Real? So we're looking again for probability, and we're looking at Get Real, okay? But some really important thing here, at least 360 people. We're not going to get an equation here, but instead we're going to get an inequality, okay? But first, let's start with an equation. Let's start with our equation for Get Real. So r is equal to 2p plus 300. Now, I want the attendance to be at least 360 people. So that means that it can be 360 or more. What sign should I change this equal sign to? Well, I'm going to change it to this. So I read this as r, or the attendance, is less than or equal to 2p plus 300. Now, when I substitute 360 into this, let's see if this matches the question. Okay, so 360 is less than or equal to 2p plus 300. Or I can think of this as 2p plus 300 is greater than or equal to 360. And I believe that is exactly what we need to find here. Okay, so now we're going to go ahead and solve for p. Now remember, solving inequalities is the same exact thing as solving, or it's not the same exact thing as solving equations, but the process is identical. Okay, so I'm going to go ahead and change this back into an equation here, and I'm going to go ahead and solve for p. Draw my line here, and we're isolating that variable p, so I'm going to subtract 300 from both sides. So now I'm at 60 equals 2p, divide both sides by 2, and p is equal to 30. Now remember that we didn't start off with an equation, we started off with an inequality. So when I write my final answer, it's not going to be 30 is equal to p. We must change this back into our original back into the inequality that we started with. Okay, so it looks like P is going to be greater than or equal to 30. And that is our answer. So this means that the chance of rain could be 30% or more, or anything larger than 30%. That will get us at least 360 people at Get Real. All right, question number 4. Is there a probability of rain for which the predicted attendance is the same at both attractions? And we give you guys a hint here. F is equal to R. Do we have equations for F and R? Why, yes, we do. So we are going to write them here, and we're going to set them equal to each other. And that is 2P plus 300. Okay, and the question is asking us, is there a probability of rain for which the predicted attendance is the same? So we need to solve for P. Now, in this instance, I notice that I have a negative P over here on the left side. And just to make your life easier, it's always nicer to move the negative variable, or the variable with a negative coefficient. That way you end up with a positive coefficient. Okay, so I'm going to move 7.5p by adding it to both sides. And remember that we have to combine like terms, so I can only add this 7.5p to the term with a p on the right side. So these are going to cancel, and I'm left with 1,000 on the left side, and this is now 9.5p plus 300. Okay, now continuing here, I'm isolating my variable. I'm going to subtract 300 from both sides. And then I get 700 is equal to 9.5p. And this is a step you guys like to skip, but it's important that you guys show all of your work. And some of you guys lost points on this on your moving straight ahead test. Okay, you have to show me that you are dividing both sides by 9.5 here. And we get P is equal to, you're not going to get the nicest number, so let's calculate it really quick. 700 divided by 9.5 is 73.68, but let's round that to the nearest whole number. So instead we're going to say that P is approximately 74%. So when the probability of rain is 74%, we can expect that both attractions at Get Real and Big Fun, the attendance will be the same. Okay, so now we have these final two questions here. It says, for what probability of rain is attendance at Big Fun likely to be greater than at Get Real? So we want F to be greater than Get Real. Well, if we know that at 74%, or approximately 74%, they're equal to each other, well, when is Big Fun going to be greater? Well, hopefully you guys said when P is less than 74%. For number 6, we want the probability of rain is, what probability of rain is attendance at Big Fun likely to be less than at Get Real? So we want F is less than Get Real. And again, this is a similar type of question. You know that at 74% they are equal to each other. And we know that when P is less than 74%, Big Fun is greater than Get Real. So the only other option that we have is when P is greater than 74%. And there we go.